let's look at the hex numbering system. And hex is also known as base 16, just like decimal is known as base 10 and binary is known as base 2. What I've done here is I've drawn out 15 different numbers. There are 16 different numbers from 0 to 15 because we have to be able to represent those in a base 16 system or hex. And I've also drawn out their binary equivalent. Now, from 0 to 9, hex and decimal are exactly the same. So a hex 3 is a decimal 3, a hex 4 is a decimal 4, a hex 7 is a decimal 7, a hex 9 is a decimal 9. Where it changes is when you have these two digits right here. A hex 10 becomes an A hex 11 becomes a B, hex 12 becomes a C, hex 13 becomes D, hex 14 becomes E, and hex 15 becomes F. So let's say we have this number right here, this hex number, F. And a lot of times you'll see this 0 and an X right out in front, and that just signifies you're in a hex numbering system and that the numbers you're using are hex. Or sometimes you might not have that 0 by, and you'll have FF to the 16th. And that also just signifies a base 16 or hex system. So if we have this 0 by FF and we want to convert this to binary and decimal, the first thing we do when we're looking at binary is we're going to look at each of these digits individually. So for this first F, we go to this table and we look at, let's do binary first, we look at what does an F correspond to in binary. In binary, it corresponds to 4 ones. So we go 1, 2, 3, 4. Okay, now my second one right here, what does this F correspond to? Well, it's the same number, so it also corresponds to 4 ones. Now we have an 8-bit number, and what we're going to do is if we had converted this to a decimal number, we'll get that this is equal to 255 in a base 10 number. Okay, so that means when we convert FF to decimal, we should get the same number of 255. And we do it the same way. We're going to take each digit individually, but we also need to remember the bit order. So our least significant bit is the bit that's the furthest to the right. And this is going to be 16 because we're in a base 16 system, and our least significant bit is to the 0. In this case, our most significant bit right here is just, there's 2 bits, so it's going to be 16 to the 1. Okay, so first let's look at this F. This F is represented by a 15. So we're going to have 15 times that bit right there. So 16 to the 1 or 16 plus, okay, F. Let's do a different color. F right here. It's also 15 plus 15 times 16 to the 0, which is just 1. So if I do that, I should get that this is, if I did it right, this is equal to 255. So 15 times 16 plus 15. I get this is 255, and it checks out. These two numbers are the same, and that is what hex FF is. So let's look at a different example, and let's look at a hex number that's 8F3A. The same rules apply. When we're looking at binary, we're going to look at each number individually. We're going to figure out what their binary equivalent is, and then that's how we represent it in binary. So with 8, okay, 8 is right here. So my first bit right here is going to be a 1, 0, 0, 0. Okay, let's look at F. Well, we know what F is. It's going to be 1, 1, 1, 1. Let's look at 3. 3 is over here. It's going to be a 0, 0, 1, 1. And we can also look at A. And if we look at A is right here. So binary is a 1, 0, 1, 0. And that is the representation of 8F3A in binary. Now let's look at how we convert it to decimal. So let's first figure out this is 16 to the 0, this is 16 to the 1, this is 16 squared, this is 16 to the third. Okay, let's start with the 16 to the third so I can write it out. We have 8. 8 is represented by an 8 in decimal. So we have 8 times 16 to the third plus f. Well, f is a 15 in decimal, so plus 15 times 16 squared. Our next number is a 3. 3 is a 3 in decimal, so plus 3 times 16 to the 1. And our last number is a. A is a 10 in decimal, so it's plus 10 times 16 to the 0. And we do know that, just simplify it really quick, this is just times 16, and this is just times 1. So 8 times 16 to the third plus 15 times 16 squared plus 3 times 16 plus 10 times 1. And we get this is equal to 36,666. So this is equal to 36,666 base 10. And these are the steps you can use to convert any hexadecimal number that you have to decimal or binary.